Hello and good evening. CSI257 students for the fall 2014 semester at Anne Arundel Community College. This packet tracer tutorial is going to be on packet tracer activity 5.3.1.2, and this is the skills integration challenge that's going to pull together all of the OSPF configuration information that we've been working on throughout this chapter. And so this is it's a fantastic activity here. And so let's go ahead and jump in. You can see we have our addressing table that we're very familiar with. And so we're going to focus on the OSPF v2 advanced configurations. And you'll notice that a lot of these are ones that we've done in previous videos. So the first requirement is to use the following requirements to configure OSPF v2 on router A and router B. And so let's go ahead and pull up router A here, and we'll bring it down. And we'll pull up router B as well. That way we can bounce between the two of them. Alright, so we'll start with router A here. So it says the requirement is to go ahead and use process ID 1 and network address for each interface, and then enable authentication for area 0. And so let's go ahead and start this up. So let's do a show IP interface brief to see which interfaces we've got assigned. As you can see, this is going to be a broadcast multi-access segment. The routers are both terminated into the switch, and my guess is, based off the IP addresses, that we are in the same VLAN, right? Probably VLAN 1. So if I were to do a show IP OSPF neighbors, we shouldn't see anything right now, and this is what we're going to go ahead and set up. So the first thing is to use process ID 1. So we're going to go from privilege exec mode into global config mode, and then I'm going to go into OSPF configuration mode here. So it's router, OSPF, and then the process ID. And so remember, the process ID is a value between 1 and 65,535, and they do not need to match within the same area. And the process ID is locally significant when we're making the assignment here. So router OSPF 1, and we are going to go ahead and do network address for each interface. So we're going to say network 192.168.1.0 and then 0.0.0.255, and these are going to be placed into area 0. Now if I do the question mark command, you can see that it's also asking us to enable authentication for area 0 right now. And so we're going to go ahead and say area 0, and if we do a question mark, you can see there's the authentication, and we're going to use message digest. Even though it's not indicating that we have to, that is the only choice that we have. So we're going to say area 0 authentication message digest. Okay, so we've got that set, and now the next thing is to set the OSPF priority to 150 on the LAN interface of router A. And so the priority is what gets set for the DR BDR election. So I'm going to go ahead, and I can't remember the interface, so do show run IP interface brief. I'm sorry, do show IP interface brief, and we're looking at gig 00. So if I say interface gigabit Ethernet 00, and this is where I'm going to say IP OSPF priority, and you can take a look, you can see there's other options here, and we're going to come back because the authentication is going to need to be set here shortly. So priority will be 150 on the LAN interface for router A. And so we're going to go ahead, we'll walk through router A here all the way down to the next section. So let's see if there's anything else. So OSPF MD5 authentication key ID of 1 and MD5 key Cisco on the LAN interfaces as well. So IPOSPF, and I'll do a question mark. So we'll say authentication and message digest. Whoops, I'm sorry, I want authentication key. Authentication key, and so I'll do a question mark here. So we're just going to say key ID of 1, and then it's going to be Cisco. Whoops, Cisco, and we're going to say, and actually we want to do MD5. Authentication key 1, Cisco, and we'll come back to the MD5 here in a second. So the next step is to set the hello interval to 5 and the dead interval to 20. So IPOSPF, and if you do a question mark, you can see that there are your hello and dead interval. So the dead interval is going to be 20, and the IPOSPF hello interval is going to be 5. All right, and IPOSPF message digest key. The key ID, I apologize. I'm going to have to go back and change that. MD5, and the OSPF password key. Of Cisco. So let's do a do show run interface GI00. Okay, do show run. I think I'm going to pull one of the commands out there. Yeah, I think I've got the no, and we'll do the IPOSPF authentication key Cisco here. All right. So we may need to come back and troubleshoot that. We'll see what happens here. So next it says use the following requirements to configure router C. So the first thing we want to do is we want to bring router B up to speed here. So let's go ahead and go back and go from user exec into privilege exec on router B, and then into global config. If I do a do show IP interfaces brief to take a look at my interfaces, I'm also using gigabit Ethernet 0/0. So I'm going to say router OSPF 1 for the process ID, so we'll use that process ID there. I'm going to have a network statement for the interface 192.168.1.0, 0.0.0.255, area 0. All right, and so that is going to start the OSPF process on any interface on the router, and in this case we only have one where the IP address falls within that range, that /24. Okay, so enable authentication. So if you do a question mark, you can see that you've got a bunch of different options. So area 0 is the area that we're interested in, and this is where you would have the authentication, and we're going to be using message digest, right? And so we've got that set. And now let's go ahead and we're going to jump in interface gigabit Ethernet 0/0, and here's where we're going to set some parameters, and we should see an adjacency established here. So the first thing we're going to do is set the priority, so IPOSPF priority, and the priority for router B is going to be 100, which means when the two routers are trying to hold the election, we should see router A become the DR and router B become the BDR. And so I'm going to save my config here, and you guessed it, we're going to do a debug IPOSPF adjacency because I want to see what happens here. And the same thing on router B, set the priority to 100, do debug IPOSPF adjacency. So that way we can see what happens and capture the activity as it's taking place. Okay, so we're still in interface gigabit Ethernet 0/0. And what we're going to do now is we're going to go ahead and set the OSPF MD5 authentication key, so IPOSPF, and if you take a look at the message digest key, we're using the key of 1, and then we're going to be using MD5 and Cisco as the line. And so when we enter this, what we might see is a little activity, but we might not, because both the hello and the dead interval need to be changed. So IPOSPF dead interval, we're going to change that to 20, and then IPOSPF hello interval, we're going to change that to 5. Keeping in mind that both the dead interval and the hello interval need to match in order for the adjacency to be established. And so, as you can see here, we've got some really nice information. There is our DR BDR election, and again, something to notice here, and this is often something where when you're asked what's elected first, is the DR elected first or is the BDR elected first, you can clearly see that the BDR is elected first and then the DR is elected. And so what do we have here? We have a priority of 150 on router A, and we have a priority of 100 on router B. And if you remember from the other evening, the higher priority, and I'm going to see if I can do a better job here in drawing this out. So the DR slash BDR, right? The priority goes from 0 to 255. Okay, 1 is your default. 0 says don't participate. So do not participate. And 255 says make this guy, make him the DR, right? And remember, we talked about the 4 criteria and how they're evaluated. So again, in the DR BDR election process, the first criteria that's looked at is actually the highest OSPF router priority, right? So highest priority. And then the second factor that's taken into account is the highest router ID. The third thing that's taken into account is the highest loopback address. And then the fourth thing is just simply the highest IP on a physical interface. So on a physical interface. And let's put physical IF for interface. Okay. And so as we would expect, right, the router A with a priority of 150 is going to be a DR. Router B with a priority of 100 is going to be our BDR. And again, doing the debugs gives us, again, some fantastic information. You can see here that the LSAs are being built, right, and that the election has taken place. So at this point, if I were to type in do show IPOSPF neighbors, we would see that from router B's perspective, it has a neighbor with a neighbor ID of 192.168.1.1. The priority of that neighbor is 150. The OSPF state machine, it's full, right? They've got a full adjacency right now, and router B sees router A as the DR, right? And it's really, and again, I don't know if I said this in the preceding videos, but the concept of the DR is really sort of a pseudo node, right? So, and you'll hear it referred to that often as just simply a pseudo node. And then we've got our IP address and the interface out which we can see that neighbor. So if we pull up router A, again, some really nice output there from the debug. If I do a show IPOSPF, not interfaces, but neighbors, you can see that the IP address, or I'm sorry, the neighbor ID is 192.168.1.2 with a priority of 100, and the adjacency is full because we're on a non-broadcast multi-access network. We've got a BDR here. So A sees B as the BDR. So everything looks good there. So this says use the following requirements to configure router C OSPF v2 routing. So let's come over here to router C, and my guess is that this is going to be an ASBR because I can see it's got a serial link out to the internet. So chances are we're going to be originating a default route here. Okay, so for router C, we're going to use process ID 1. So we're going to go from user exec mode into privilege exec with the enable command, and then the from privilege exec into global config, and then we're going to go ahead and go router OSPF with the process ID of 1. So we're going to use a network statement for the LAN interface 192.168.1.0 .255 area 0. Let's make sure it's in area 0. It is. So set all interfaces to passive by default. Allow OSPF updates on the active LAN. So if we do the question mark here, you can see this is where your passive interface command is. So to be passive interface default, and that is going to passive interface all of the interfaces on there with the exception of the LAN interface. And so what we're going to say here is no passive interface GI 0/0. And so if I were to do a do show run right now, and that's kind of a tricky one there, right? So they tell you to, whoops, went right by there. They tell you to make all interfaces passive, so you would do passive interface default. However, they then tell you to make sure to allow OSPF updates on the active LAN. So the local area network is this network here, right? This is the wide area network, okay? And so then you've got to make an exception by using the no passive interface gigabit Ethernet 0/0. All right. So we've got the interface assigned, and then authentication. So we're also going to be enabling authentication for area 0. So again, if you do the question mark, you could start with area 0 and then do another question mark, and this is where you would see your authentication and message digest, and so we'll hit enter there. Alright, so we've enabled authentication for area 0. So set all interfaces, we did the all interfaces to passive, set the router to distribute default routes, right? So here's where you do default information, and if you remember, you're going to do originate, right? Keeping in mind, and we'll talk about this a little bit more later, I've actually made this look just like the lab, where these are going to be wide area network interfaces here, and we're going to take a look at how simple it is to change the type of external, or the type of route that's being originated into OSPF area 0 from an E1 to an E2 or vice versa. Alright, so we're going to do default information originate. However, we have not set a default route. So we've set the router to distribute the default route, right? However, let's do a do show run here, and I don't believe a default route has been set up at this point, and it has not. So that's something that we're going to need to do here. So it says configure a directly attached default route to the internet, and that's exactly what we're going to do. And so when they say directly attached, we're going to do a do show IP interface brief, and we can see serial 000, that is our link out to the internet. So we'll do IP route and then the quad zeros, and then we're going to say serial 000. Now it's going to tell us that the default route without gateway, if not a point-to-point interface, may impact performance, but we've got a point-to-point interface here. And so now if I were to come over to router A and do a show IP route, you can see that it's telling me that the default, the gateway of last resort is not set, and that's because we still have some configuration. You'll notice that we didn't do any configuration on this LAN interface for authentication or for timers, right? So we still have some work to do. Debug IP OSPF adjacency. It's always nice to see any messages that we receive. Alright, so the OSPF priority is set to 50 on the LAN interface. So gigabit Ethernet 00, we're going to say IP OSPF priority, and we're going to set that to 50. And this is below the 150 and the 100. Now, if it was higher, remember that with the DR and the BDR election, that it would not preempt it. So even if I set this to 250, right, it would still be a DR other or a druther, because it's not going to preempt the current DR and BDR election status. So even if you set this to a higher value, it would not kick in until an election were to take place. So IPOSPF priority of 50 on this interface, and then we're going to go ahead and say the OSPF, IPOSPF authentication, or I'm sorry, message digest key. Message digest key of 1, and it's going to be MD5, and we're going to use Cisco as the password. So Cisco is the password on the LAN interface, and even with the message digest set correctly, the adjacency with router C to both routers A and B, and actually that's something key to keep in mind, right? That router C will form an adjacency with A and B, so it'll be full with A and B. However, if there was a fourth router that was in this setup for whatever reason, right? And let's get where's desk scribble? There we go, desk scribble. So if there happened to be a fourth router, and let's say that it was, we'll put it out here and let me drop down the line to make that a little thinner. So if there was another router out here, let's say this is router D, right? And let's say that router D was plugged in here to the switch. So this is our DR, and this is our BDR, right? And remember that these guys have already been elected. There is no preempting this when we set a priority on router C. So when router C comes online, he's going to be a druther. And what's going to happen is he'll establish an adjacency with the DR and the BDR, right? However, he'll only be in the two-way state with this other router here, which is also a druther, because the adjacency is only fully established with the DR and the BDR. So he'll see this guy here, he'll see router D, but they do not establish a full adjacency with each other. So that's just something to keep in mind if you had additional routers, because remember, there's only ever a single DR and a single BDR on the broadcast or non-broadcast multi-access segment, right? And everyone else would end up being druthers. Okay? Whoops. So let's clear that out there, and then let's drop back here. All right, so the final thing that we're going to do is IPOSPF hello interval is 5, and the IPOSPF dead interval is 20, right? So there's a note here, and it says to issue the clear IPOSPF proc command on router C if the default route does not propagate. But let's see here. So first we've got to have the adjacency established. You'll notice, right, true to form here, that we've got some LSAs going back and forth, and the OSPF state machine is in the exchange state, and it's transitioning through from exchange start, right, to exchange. And you can see here that the DR BDR election, there was an election between the DR, which is 209.165.225, and 192.168.1.2, right? So sending database descriptor to 1.1, and the DR is, as you can see here, the DR is still router A, and the BDR is still router B, even though, or I shouldn't say even though, we set it to 50, so it was less than their priority. So we're good there. All right, and so the adjacency has fully established at this point. So let's go ahead and do a do show IP or do show IP route. And as you can see, the gateway of last resort has been set, and here it is right here. It's directly connected to serial 000. Let's see what router A sees if I do a show IP route. And sure enough, router A sees an external type 2 route that's going to take it over to 192.168.1.3. right? And so B is also going to see an external type 2 route. So we'll go from user exec to privilege exec into, well, actually not in global config. So we'll do a show IP route here, and again, it also sees a type 2 route. So if you remember from the other night, one of the previous videos that we did where we were using router C was serving the function of an ASBR, where it is originating the default route into the OSPF area so that all of the other routers have a default route and have a gateway of last resort. And we talked about the difference between an external type 1 and an external type 2. And so the key thing to remember here is that with the external type 1, if you had, you know, additional routers out here, so we'll put one here, and then maybe you had one here, and let's say that this router also had a link out to the internet, and it was trying to get to a different web server, right? So, and it might be that you've got a LAN segment over here with some switches, right, or a switch, and then you've got some hosts over here, so we'll say this is a PC. So what happens is we're originating this default route. However, there may be costs associated with other links in your architecture that you want to have calculated into the overall cost to get to that default router, to get to that gateway address. And so with the type 2, the external type 2, right, any additional internal costs are basically ignored and not added on to the cost of that route to get out. So with the external type 1 or the E1, right, if it's a type E1, then those costs are calculated. And so here, in this scenario here where we have a single exit point out of the network, and let me clear the rest of this out. So where we have a single exit point to get out of the network, it's not necessarily a big deal if it's an E2, right? However, if your architecture is going to grow or your network's going to grow, there's nothing wrong with forcing it to be an E1 route. And what this does is this sets you up for success down the road, because there may come a time when you do want to take into account the costs, right? There's a cost here, you know, the costs of the other links, and maybe this guy's going out to the internet, right? So you would want to set it up. If you're setting up your environment and you've got an ASBR and he's originating a default route, or even if originating any route, right, from externally, and if that route is an E2, there's no reason not to set it up as an E1 if you want to take these things into account. Again, if there's only a single exit out of your network, then an E2 is going to do just great. However, when your network scales and you have additional exit points, it's probably going to be in your best interest to use E1. So let's go ahead and clear this out. And I'm going to pull up, and I'm hoping that I still have these guys up here. So we've got router 2. I think this is probably going to pull up every single window that I have here. So we're going to move this to his own session here. And I could have swore that we had router 1 earlier. Let's take a peek. There's router 3 and router 1. Okay. So I'm on router 1 here, and I'm in this GNS3 setup over here. And so we're going to hit enter. So we'll go from user exec to privilege exec, and we'll do a show IP OSPF neighbor. And you can see that we're neighbors with 10.10.10.2, and it's this guy right here. This is 10.10.10.2. And we're in a full state, and he is a DR. So if I do a show IP route, you can see that we're doing default information originate on router 2. So we'll go from user exec to privilege exec, show IP, or I'll actually do a show run section OSP or router OSPF. And so this will show me the OSPF section of the config, and only that section. So you can see we're doing the default information originate. If I do a show IP interfaces brief, and actually let me move this up since it's kind of down at the bottom of the screen there. You can see that we've kind of set it up similar to where serial 10 is sort of our WAN interface, and then router 2 is serving as an ASBR here, and it's originating an external route into the environment. Now, remember we had talked about the differences between E1 and E2, and again, a lot of students ask, well, if it's an E1 route or if it's an E2 route, which is the default, how do I change the metric type so that it is an E1 route if that's what I wanted to do? So again, E2 is the default, and it's going to come up like this by default. So if I were to come over here and say, go into global config mode and then do router, and what is our OSPF 1, right? And I'll say default information originate, and when I do the question mark here, you can see that we have some different options that were not available with Packet Tracer. So I'm going to go ahead and say metric type, and there they are. So I can make it a type 1 external route, an E1, or I can make it an E2. And so again, by default it's E2, so we're going to say E1. Or I apologize, just 1, right? So metric type 1. So over here, when I run this command again, you'll see that immediately it changes it to an external type 1 route. And so again, in order to get it to come in as an external type 1, you just simply type default information originate, metric type 1. So what happens if I just say default information originate, metric type 2? Does it automatically change it? It does. So what if I just go ahead and say default information originate? It's already type 2, so chances are it is still type 2. And then let's see what happens if I do default information originate. We're going to change it to an E1 again. And does it take place immediately? It does. So you can see it's immediately picking that up as an E1. And so another thing to notice is you'll notice, remember we said that the E2 is the default, and you can see that the cost is 1, right? However, when it changes to an E1 route, as we said, the E1 route cares about the costs and adds those costs in, right, in addition to the cost of the route. And so you can see here that the cost is 11, okay? And so that's the big difference. So as an E2, router 1, right, receives this E2 route, and it just simply knows that, yeah, it's a cost of 1 for me to get from R1 to R2 to get to this route, and it doesn't care about any additional costs. An E1 route does, okay? And again, this may not be too specific or too relevant to what you're doing today. However, it's definitely something to keep in mind. And again, it's very simple to do. We already know the default information originate command, and then we just simply select what type of metric do we want. Do we want an external type 1 route, or do we want an external type 2? But let's see what happens if I just say default information originate. I'm curious to see if it's going to drop back to an E2 automatically, and it does not. So what if I were to say clear IP OSPF proc, and we'll say yes, and this should reset everything. If I do show IP route, oh, I'm sorry, if I do a yeah, correct, show IP route, let's see what it sees. It should pick up, there it goes, it still picks it up as an E1. So interestingly enough, if you set it to a type 1, you can't simply put the default command back in there and have it change it to a type 2. We're going to actually have to say metric type 2, and then I'll come up here and we'll see that now it is a type 2. And again, notice that that cost with a type 2, right, the E2, external type 2, the cost is simply 1. So E2, it doesn't care about adding up other costs for other segments of the network, whereas the E1 does calculate that in. Okay? All right, so let's go jump back over here. I think we're complete over here. We are. It looks like we're at 100 out of 100, and so let me do a quick check here. Verify your configuration, test connectivity. Neighbors should be established and routing tables should be complete. They are. RA should be the DR, RB should be the BDR, and all 3 routers should be able to ping the web server. So let's go ahead and do that right now. So 64.101.2, and we're actually able to do that from user exec mode, and so we'll go to router B, and we'll say the same thing, ping 64.100.1.2. And we've got success there, and then we'll hit router C, and router C should definitely be able to ping it. Ping 64.100.1.2. All right, and so we're also 100 out of 100. So again, to recap, the DR-BDR election process, okay? Here are your priority values, right? 0 to 255. 1 is your default. 0 says, I do not wish to participate in the DR-BDR election. 255 is where you're specifying, hey, I want this guy to be the DR, okay? And then how are the criteria evaluated? They're evaluated in this order right here. So it's going to look first at the highest priority. It's then going to look at the highest router ID. It will then look at the highest loopback address. And then if all else fails, it's going to just basically grab the highest IP on a physical interface, right? And so these last two here, the highest loopback and the highest IP on a physical interface, you probably don't want to get to that point, right? So make sure, best practice, make your network deterministic. And what I mean by that is set your priorities so that you know who your DR and your BDR are going to be, and you also know who the other routers are, or which other routers are going to step in if for whatever reason there's a failure. And it's always a good idea to set that router ID to something that is indicative of or identifying for that router, right? And then as we saw over here, the difference between the type 1 and the type 2 external routes, right, where the E2 is your default, and the external type 2 route doesn't really care about any of the other costs along the way. It just simply gives you a default cost, right? And it doesn't add in any of the other costs along the way, where the type 1 external route does care about those costs and is going to add those in. And as we saw, not there, but I think it's behind this window here. I have to drop this down. Yeah, it's behind this window here, where with the type 1 route, right, the type 1 external, it does care, and it is going to add that in, and it's going to impact the routing decisions that get made. Okay, so this concludes Packet Tracer tutorial for Packet Tracer 5.3.1.2, which is the Skills Integration Challenge for Chapter 5, and this is a very, very good Packet Tracer activity. All right, that's all we've got for this evening. Have a great night, and best of luck to you in your studies.